Hi everybody, welcome back to the Feynman technique. Today we'll be evaluating another integral I got off the channel Maths 505. I will link to his video in the description. So let's just get started right away. Let's just make the substitution u is equal to tangent x. Now I'm not going to show what everything else is equal to based on that. Go ahead and you guys can do that yourself. But if you perform that substitution, this is what our integral becomes. I don't want this video to be too long, and performing that substitution is just a lot of busy work. This is what you end up getting. All right, so for our next step, we're just going to solve this using classic Feynman integration. I believe Maths 505 used the gamma and beta function and expressed his answer in terms of the golden ratio. But we're just going to be using strict Feynman integration to solve this. So we're going to let f of t equal this integral. And you can see that all I did was replace this 1 with a t. And I excluded that factor of 1/2 in front also. But from this, we can see the following, that our original integral, our target integral, is 1/2 of our function of t evaluated at f is equal, or at t is equal to 1. And you can see pretty clearly that f of 0 is going to give us 0. All right. Next, let's take f prime of t. I misnotated f prime of t. I put f1 of t. Just know that that's f prime of t. We get f prime of t by taking the partial with respect to t of the integrand of our original f of t. And if you take the partial with respect to t of this right here, this is what you get. So our f prime of t is equal to that integral right there. All right. Now let's perform the substitution x squared is equal to t times z. And you get all the rest of the stuff from that. And plugging those values into our f prime of t, our f prime of t becomes this. Again, pause the video and verify that for yourself if you'd like. But this is what you end up getting. Great. So now we have f prime of t is equal to this. Now, from my video, The Power of Complex Numbers, number 7, in that video, I derived the following formula. That the integral from 0 to infinity of 1 over x to the t plus 1 dx is equal to this, pi over quantity t times sine of pi over t. All right, now we can manipulate that formula a little bit with this substitution. U is equal to xt. And if we perform that substitution, we end up with this. That 1 over t times the integral from 0 to infinity of u to the quantity 1 minus t over t over u plus 1 du is equal to pi over quantity t sine of pi over t. All right, so if we let our t equal 10, we end up with the following. You can see I just let t equal 10, so we end up with 1 over 10 times the integral from 0 to infinity of u to the 10, or 1 minus 10, which is 9 over 10, so u to the negative 9/10 over u plus 1 du is equal to pi over 10 sine of pi over 10. All right, multiplying both sides by 10 gives us this. And this is exactly part of our f prime of t. Don't forget, our f prime of t is this. And we just figured out what that is using that modified version of the formula. All right. So we know that this part of our f prime of t is equal to this. And using that, our f prime of t is simply this. Okay. Well, that's a very easy thing to integrate. So we need to integrate that to get back to f of t. So integrating that, like I said, that's very, very easy to integrate. We end up with this. Great. So now we have f of t explicitly, except for this constant of integration. But we can use the fact that f of 0 is equal to 0 to solve for c. So if we plug in f of 0, we know we get 0. but we also get 0 plus c. That means that c is equal to 0. All right, so now we have it. Now we have f of t. This is f of t explicitly in terms of t, not as an integral. And we know that our target integral is equal to hold on one second. Yeah, that's the 10th root of t. Okay. I meant to write t to the 1/10th, but I guess the 10th root of t will work also. Okay, so I is equal to f of 1. So if we plug in 1 for t, we just end up with this, and that's the answer to our integral. Therefore, this integral is equal to negative 5 pi over 4 times sine pi over 10. Now, that's kind of interesting because I know for a fact this is true, but I also know for a fact that the answer that Maths 505 got is also correct. That means the two things are equivalent, which is kind of neat. I guess this is related to the golden ratio somehow. I was not aware of that, but apparently it is. Anyway, hope you guys enjoyed that, and we'll see you next time.